alaikum. Welcome to the Department of Electrical Engineering in the College of Engineering and Sciences, Institute of Business Management. I represent the Department of Electrical Engineering, being the head of department. My name is Dr. Imran Majid. The Department of Electrical Engineering has a vision to produce entrepreneurial engineers who have a critical mindset to develop solutions for the industry and for the future. So our focus is on innovation, innovative products and processes. Welcome, and I will show you more about the department in the future. Welcome to the Electrical Engineering Department Labs. The Electrical Engineering program is accredited by the Pakistan Engineering Council. We are currently under level 2 for batch 2016 and level 1 accredited for 2017 batch. What level 2 means is that our students are proficient in going across the world to look for job and education opportunities. The big element of the electrical engineering program are the lab work. In the terms of lab processes, the senior design project or the final year project plays a crucial role. One of the most important things that has evolved out of this department is the number of different funded projects that have come out. So in 2020, we had 3 funded projects from the Ministry of IT and Telecom worth up to 200,000 rupees. In 2021, we had about 70 to 80,000 rupees per project. That means about 160,000 rupees. These projects range from different areas of industry. So we had project areas coming from environment, we had projects coming from motion capture, and we had projects coming from agriculture and use of autonomous systems. So these 3 projects are some of the flash marks or basically the trademarks of this department. We have evolved over a number of years, and our students have become more proficient in addressing the sustainable development goals, specifically related to healthcare, specifically related to environment, and different aspects of media, industry, urban planning, and construction. This is where our graduates look for a job, and they have found opportunities in science centers, they have opportunities in power sectors, they have evolved and performed themselves in different universities across the world and are flourishing and giving back to the community. Welcome to the Department of Electrical Engineering Laboratories. Welcome everyone. March 4th is the World Engineering Day. Build Back Wiser, Engineering the Future. The World Engineering Day is an annual event. It's a day of celebration for sustainable development, and it was recognized by the UNESCO, which is the United Nations Scientific and Cultural Organization. World Engineering Day recognizes the important work that engineers can do, they have been doing, and they are expected to be doing in the future. So some of the problems that we are facing globally, which includes climate change, we have issues regarding cleaner, sustainable, more easily accessible water sources, air sources, and a better standards of life. For these, engineering will be the most crucial element in building the backbone for the future society. We need clean, accessible water. We need to look into sanitation systems, which affects people around the world. And we need to look at energy which is affordable and reliable. In this context, the Institute of Business Management, in collaboration with universities from NUST and the UNESCO, have organized a small discussion forum. Our focus today is mostly on discussing certain aspects of this disruptive technology. We will be focusing on the general applicability of engineers, how they are affecting and promoting the world now and in the future. And I'm also going to highlight some of the background about the role that engineers have played traditionally in society, which is not highlighted the way it should be. You can call it an engineering outreach session, futuristic vision of where we should be in terms of sustainability and development of the human race.
Let me recall a very famous incident back in 1921 when there was a moon close to the city of Larkana, which we now know as Mohenjo-daro. This was excavated back in 1921, and it was revealed that in the civilization that behold that moon was actually more than 2,500 years before Christ. The marvel of that civilization was the urban planners, the engineering feats that they had accomplished, and specifically 108 by 180 feet public path, which was not accessible anywhere in the world at that time. So, apart from civilizations that have gone past, we know very much the future that has behold. We have the Roman, the Greek, the Muslim civilization. All these civilizations have relied on different aspects of technology and its application. I would like to highlight the marvel of the Islamic architecture, which basically relies on the dome, the concept of the Pythagoras theorem. So basically, what we use is the relationship between the base and the height, and then we hypothesize symmetry. That has been exemplified in the Alhambra Palace in Cordoba, Spain. I'm going back from the 14th century now to the future. Here we have engineers who have developed technical expertise. We have more than 100 to 200 different fields of learning. In IoBM, we have a Department of Electrical Engineering, but we are not limited to the engineering of electronic and electrical engineers. We are managers, we are social workers, we perform work for the society. And I would like to highlight the aspects that our engineers bring with them when they graduate, which is confidence and entrepreneurship skills. Some of the areas that have been highlighted in Pakistan recently relates to agricultural output, for which robotics, autonomous systems, and future AUVs and UAVs are going to play a big role. These are things which we are trying to focus on in not only the electrical engineering program, but we're also highlighting this in artificial intelligence, in future technology management programs. So we have offered a BS in technology management just to cater to that gap in demand. I would like to also highlight an important aspect about engineering in our country. Not many of us know about Mr. Fazlur Rahman Khan. He was a Pakistani trained engineer. He was considered the father of tubular engine designs. He designed the high rises and, as you know, the Sear Towers, which has been the world's tallest building from 1973 to 1998, was actually his brainchild. I would like to now move on to what we as engineers could bring about in terms of skill sets. So we have an advantage of being well-rounded professionals. Unlike other fields, we have a command over objective analysis, mathematical analysis. We have broad skill sets, and we bring in management skills where required. I would like now to introduce some of the speakers in this discussion. Dr. Bilal Khan Sahab, he's Director R&D at National University of Science and Technology. Dr. Sahab has done his PhD from Sussex in Next Generation Networks. He will be discussing his thoughts, his reflections on modern technologies and its implication in our lives. Next, we have Dr. Abdul Hanan Sheikh Sahab. He's an associate professor of mathematics. He's with us in IoBM. Dr. Sheikh did his PhD in seismic imaging from Technical University Delft, and the topic he will be interested in discussing will be professional life of an engineer without mathematics. Just wanted to highlight some of those. The thing that Dr. Sahab will be sharing with us will be reporting on the role of college maths, which help in a career for an engineer. He will be discussing how the engineering study as well as graduation is defunct without the role of mathematics. and he will be discussing the role that mathematical skills sort of have been missing and how their role can be more enhanced in where the problem actually lies. So I will move the floor over to Dr. Khan Saab, and he can sort of start off and reflect on his ideas and stuff.
Right. Thank you, Dr. for inviting me. It's an interesting topic, to be honest. Nowadays, we have technologies at the forefront of everything, and things are moving at a very fast pace. And to be honest, I'm from that school of thought that the technology should be serving the humanity. So it should be engineering serving the humanity, doing the cause, and making the life much more easier. So be it from the virtual reality thing to the robotics and all those things. So back then, in the olden days, we could not have basically thought that we can have some remotely operations going on in the medical field. But now, thanks to the virtual reality, it is possible. On the other hand, it's a double-edged sword as well, to be honest. With the invent of the artificial intelligence and machine learning, more and more we are basically going towards the mechanized area. So technology is important. It's fundamental to us. But then again, this technology should be benefiting the humanity rather than we are basically being consumed as a data set for the technology. It's a very big debate nowadays going on, to be honest, that if the technology which is around us is there to serve us, or we are basically serving the technology. Because there was a study back then that the students which are basically investing more and more time on their laptops and on their tabs, and they basically lack some kind of a social interaction. So the human interaction is basically being replaced with the machine, and there comes the attention span as well. So the more and more we are towards the mechanized area, then the attention span is also shrinking. So no doubt the technology is important, but then they should be balanced between how much technology we require and how much technology is there to serve us, and we should be basically having the balance in between, to be honest.
I think there should be a balance between human interactions and human aspects than the logical aspects of things, what you want things to be done. And I think for increasing the logical aspects, especially developing countries, we have a lot of these social connects, but we are now trying to do social entrepreneurship to cover that gap. But obviously, this still is not there where it should be. I think some of the gaps, apart from social entrepreneurship and other things, is the gap in pure sciences. Exactly. So one of the sciences that I think we as a nation and developing countries, we have an issue with highlighting is the field of mathematics. And I think Dr. Sheikh Saab will be now somebody who's an expert here, and I think you've been raising this for a couple of months now, that why the maths is so important for engineers and how it could actually take them to a different level.
Thank you, Dr. for having me on this day. I think it's remarkable to celebrate this day, World Engineers. There is no question importance of engineers to the society, right? And they serve in every aspect of the life, basically to the humans. So what I was thinking, the engineers, so they face challenges in terms of environment, the sustainability kind of thing, and I see that as a challenge of lack of mathematics. So I will strongly advocate and try to put in that framework. So what I understand the engineers do is they do multiple jobs, starting from planning, designing, manufacturing, processing, development, maintenance, and in the end maybe safety and health and environment protection. So nowadays it's very hot. So in our surrounding, what we see mostly the engineers do their processing and manufacturing job with focus, but planning, designing is somehow, lack that focus which is on the processing and manufacturing, and in the end safety and health and environment is also, that deserve more attention nowadays. So this lacks because of the intensity or the seriousness of the mathematics to the engineering education and even the post-education career path of the engineer. So when they miss out this segment in education, and which also consequences they feel lack of those skills in their career or the professional life. So So planning and everything is missing, and I would like to highlight some of the points which causes this is maybe I would try to recall one survey. The college mathematics, interest in college mathematics you mentioned, I intimated you. So interest in college mathematics leads to students to decide for the engineering education, and when they reach to the final year of the engineering program or their graduation, so we almost see their interest in the mathematics which they carry in the college mathematics. So that is almost lost somewhere. So that is because of some reasons, and so few reasons. So one is like the teaching, and the next is the content what we are try to teach to the students, the mathematics content. And in my opinion, that is a bit impractical, right? So we have some exaggerated goals. So when we design the mathematics courses, so there is lack of coordination between mathematics teachers and engineering teachers. So when there is a coordination, they can come up with a very doable content, and also the teaching methodologies. So there is research which tells us that when a science teacher teaches mathematics and an engineering teacher with a background of engineering education teaches mathematics, they yield different outputs.
Yes.
So yeah.
I think they complement each other.
Yeah, kind of, exactly.
Yes.
So these are some of the challenges, sure. Right? And also one challenge is in the post graduation is like organization do not encourage the mathematical skills. True. And training, right? Training of the engineers. Yes. And kind of thing. So
I agree with that.
Yeah.
So I think there are some good points coming out from those discussions. And you from my analysis, you're stressing the importance of multidisciplinary interaction
exactly,
between the natural sciences, the pure sciences, and applied sciences, where engineering comes in.
As you know, that the definition by the famous Merriam-Webster dictionary, the definition of engineering is applying science and mathematics to get best of the matter and energy for humans. So it starts with like applying science and maths to get best of matter and energy for the betterment of humans. So engineering is like
And modern technology, the basics of the modern technology is on mathematics.
Mathematics and sciences, pure sciences.
Computer science, algorithms and all those things.
I would say even chemistry, the basis of chemistry, some of the engineering areas, they cannot live without the basis of the chemistry.
And I think that brings me to another point, which I think, because I focused, when I was doing my research, I was looking at solutions which, you both are able to recognize that, solutions which are not easily solvable, NP hard problems. So uske liye we have to move to a different mindset, heuristics ke andar. And then we get inspiration from nature, we get inspiration from social contacts, ant colony optimization. I worked on genetic algorithm. There was a particle swarm optimization problem. So we get inspiration from what we see in the nature, what you mentioned initially, that you wanted to see that there's a disconnect between the human aspect or the nature aspect for which we are designed. We are also designed by a perfect engineer, a perfect creator, but we are not performing the way we should be, and to correct those things, we are relying on our own small, you can say small creations, but we don't realize that there's a connect which we can establish, and we need to kind of balance it out, because if we are mechanically oriented, we won't be having all those emotions and feelings, and we won't be growing as civilizations have evolved over time. I'm surprised to really see, if you look at disaster reduction, disaster mitigation, especially in Pakistan and other places, there was a report which said that Pakistan is one of the only few countries where after an earthquake or repatriation of refugees, people are able to come together as a community and develop it. You can't even see something happen. And if there's a report from the American press, in Haiti they had a disaster, and there are still remnants from that effect, because the people are not bonded together. They rely on some other source of help. So those are things, I think, which help us have the human touch, and I think that's what you were highlighting there. But obviously you can't live in Stone Age, where you have to grow, you have to make the technology work for you rather than we feed the technology, which I totally agree with.
And this is the high time that we should be basically going towards another thing which we coined it, way back, that engineering without borders. There should be no borders available. The engineers can basically have shared the ideas, work on an ideas, do collaborations and all those things, so that every society should be benefited.
Correct.
And because obviously we have some developed countries, we have developing countries, so the boundaries are there in terms of the engineering and working for the engineers. So there should not be any boundaries. The collaboration should be free. They can basically share the ideas and implement them for the sake of the society.
True.
So society comes first. Whatever the projects one can be.
It actually brings to me an important project. Just came to my mind. We're working on basically analyzing physiological signals like emotions. These are psychological signals, and then you have a physiological signals, which means your heart rate, oxygen saturation. So those are things which our engineering department has actually worked on. We are filing a patent on that. So we are trying to see remotely how to, using wireless and using technology, how we are going to give those first aid or emergency response, not even to just elders and aged people and people who are in distress, but also to kids. So in our society, we don't report child abuse, we don't report child kidnapping and ransom. Those are human aspects, and one of those things that I think technology can help us, which we are filing a patent for, is location tracking. So if your child goes to the school, you're able to trace and track what time they got off the van, where are they located right now. If they're in stress, then their stress monitor will actually report to a central authority, and for that we need some sort of IoT-based systems. So IoT is one aspect that we are covering, not even in the B electrical program, but also in engineering management and the MS in electrical engineering. We have projects which are funded by the Ministry of IT and Telecom. Some of the projects that are related to these aspects. One of the things which you'll see behind you is related to motion sensing. So if you have patients who have issues with monitoring or traveling or prompting, they can be monitored remotely using AI, using VR, using AR. So this is a whole new area, I think, which needs a lot of investment. We got initial funding grant for that. I think one of the students is also in the audience. We were working forward for using the current wireless signals to sense the stress level or the happiness level. So that means that you won't be having
other factors
stuff
like
to you.
heartbeat or the temperature, they
Correct.
can also contribute to the stress. And
Exactly.
recently, maybe thanks to pandemic era, so it has put more emphasis on these things like distance teleconsultation, or
That's the point.
as you said, the remote first aid without getting into contact by any human, maybe. So
That's it also raises ethical issues, right? Some people say, oh, why are you monitoring me? Ab wo ye hai ki you're a group, you're monitoring in a group.
Exactly,
But
yeah.
obviously there's a lot of ethics to that. But
This is still in its
infancy, true.
One needs to basically work on those issues as well.
True.
And then, very rightly pointed out the technological aspect that if in the past we have a lot of fires going on in Karachi area from different industries. So what we at NAST, at PNEC, what we have developed is a firefighting autonomous drone system, which basically tries to eradicate the fire in its, to be honest, in early stages. Rather than it will become a category 3 or category 4 fire. We can basically, drop a ball which can basically diffuse the fire in its starting stages. So, technology is everywhere, and we can basically benefit from the technology a lot, until unless it is for the benefit of humanity.
And I think this raises another question, because we are just not human beings, we are also part of this whole ecosystem.
Exactly.
So we had a project on dolphins. So a dolphin is an endangered species which there's no proper mechanism to stop its unnecessary hunting, which there are excavated areas between, I think, Kotri Barrage, around those areas, and Guddu Barrage, and the numbers have been declining. But we had proposed a remote wireless tracking system. So what we do is, using acoustics, We actually monitor their behavior, their stress level. And the beauty of this thing is, like which you mentioned about the human beings, that they're not being actually monitored. They don't know, because we are only hearing what people are hearing from them, the sounds. They don't see
Waves,
they have these acoustic waves, and we're just monitoring them and then making some changes in their environment. So for example, if there are barrages, we're opening the gates, we're stopping the flow somewhere, we're letting them have access. So those are things which I think in the future we need to work together in those areas, and especially with the human aspects, but not without technology. We need the predictive maintenance. For predictive maintenance, for prediction, we need AI. For AI, we need algorithms. For that, we need to have a very good grasp of logical thinking, which is what maths is all about, right? So if you don't have those skill sets, I mean, it can be all applied in different areas. So engineers, they don't just come out as engineers. They can go into as analysts. They can go into mathematics. They can go into financial media. They can go to management aspects, because management also requires a lot of logic, right? So you have to compartmentalize things. You have to do it in a logical pattern, which I think most of you agree with that it's a flow which works. And management brings, where you are talking about the human aspect, with the skill sets that you develop as an engineer, or with the logical flow which comes from the mathematics. So I think those are very, very important things, and we need to do it for our own sake,
For humans, of course. So
what we are leaving for our future generations. I mean, the climate change there have been some Kyoto protocols, there have been Paris protocols, but I think we are, as a nation, we build trees, we have urban forests, but we do it on a very limited scale. We don't sort of recycle things properly, or we don't have a mechanism, say for example, for cleaning our ocean. So when you see on the backside, you will have a marine drive cleaner. You will also see fuels which are basically not the normal hydrocarbon based. So you use, say for example, energy from footsteps, exactly, tidal energy waves generators. So these are things which we have as a department, we have focused on, and I think we should all benefit from those technologies as well, have some future collaborations. Industrial linkages is also very important, because those help the engineers get a job, but also the industry will be sort of motivated to work towards, climate change aspects and sustainability. Those things we can generate for them using these beautiful ideas that, you guys have been working around. So once we finalize all this, I think we need to emphasize a couple of things that what we agree to is basically the civilization aspect of humanity is incomplete without engineering.
True.
Right? Engineering is incomplete without having a logical and mathematical strong base.
And all other sciences, basically.
Or other sciences, or natural
basic
sciences. And we also agree that engineering stand alone, or just making robots which are actually fed data and then outputting stuff which we are predicting ourselves, is no help to the problems we have as a human race. So it has to be in coordination. So vice versa. So I remember there was, we used to have a maths Olympiad. We used to have summer camps when we were in our young ages. And in those Olympiads, we used to always work on the human aspects. We used to always say, what will this benefit our race?
Yes,
like, society ko kya fayda hoga? We have problems of, say, we don't want to track people. वो तो एक तरह से वो हो जाएगा, but we don't want the society to. I think it's social fabrics भी तो है ना आपके. Like what you said, technology technology has brought us away from each other. We focus more on ourselves, on how we interact remotely through a mail, but we don't have that human interaction. वो I think it should be there. Future mein, I've heard that they'll be going to use halos. We're going to interact while you're sitting in your office, and you will be in a 3D
about technology. So the ultimate end of the technology that will lead us either to the caves, or we will be extinguished like a species.
Yes.
So these two of the situations will be there.
So I think these are very good aspects, and one of the strong aspects that we as a department have been focusing on right now is we have a plan now for but the next year we are going to be focusing strongly on technology aspects. how technology management is going to help us, how the application in the real world. We have a number of future seminars like these planned out. We have more very well-defined outlets. So, for example, we have industrial collaborations with the automotive sector, with health sector. We have a plan for developing these skill sets on a very large basis, and we're going to ask people from all disciplines. So, for example, our technology management program focuses not only on engineering graduates or pre-engineering, people with a medical or a commerce perspective. They will be basically acquainted with the skill sets, mathematical skill sets, social entrepreneurship, technology management. This will bring them in par with the engineers of the future. So they will be engineers, but they will think like engineers, but they will be managers, they will be professionals in their own entities. Interdisciplinary challenges is very, very important. I myself, University of Warwick, I myself represent there. You've been visiting as well internationally, and mashallah, also you have a lot of contacts in Delft as well. We, as society, we are, we work for IEEE. It's the largest technological organization. So we have a Karachi section for which we have in our faculty 3 or 4 members who are very, very active. We have 5 to 6 projects funded every semester, which we are also propagating in the future. And we have a plan to further enhance this using collaborations and international ventures in promoting our AI, artificial intelligence, autonomous systems. We're going to do predictive maintenance. We have plans for developing all these and also for policy making. So all this will lead to electric vehicles or UVs. You will not be in ice silos, but this will be in cognition with the other with the policymakers, so we can impact society in the future. So thank you very much, gentlemen, for the discussion. We really had, I think this was a very interesting talk, and hopefully will lead up to further talks in the future. So hopefully we can talk this more in certain depth and certain topics of interest, inshallah, in the future. Thank you for your time. Thank you. The project we now want to introduce is related to 3-axis kinematics study using motion capture for augmented reality. Here we have a student, Mr. Ali Gohar, who will explain the features of the project and its application vis-a-vis real life. So over to Ali Gohar.
So basically we have used MPU 6050 sensor. For MPU 6050 sensor, which is attached with Node MCU. When we move the sensor, it will extract the values of 6 DOF and it will mount on the part of the skeleton where we have connected this. And application, it is basically used in media department, industries, different industries. And what is the specialty of our project is to reduce the noise. We have used the wired sensor, wired system, and it is less noisy than available sensors.
The commercially available sensors, correct.
And it is cost effectively. We have designed 2 sensors on upper and lower arm for right arm, and it can be we can extend it for all the body, and it is cost effective. And
where did you find the finances for this project?
So we have a grant is approved by Ignite, and we have.
And Ignite is the Ministry of IT and Telecom.
Yes.
So this body which funds FIPs like.
FIPs. Yes.
How much funding did you get?
So 72.
72,000,
okay.
Which includes all the hardware,
software, miscellaneous, and all the.
Sure. And you're currently working somewhere? Can
yes,
you
sir.
Explain what.
So I am currently working in Watson Private Limited as a CAD designer, and it is a part of a tech group.
Right.
Tech group company.
So those skill sets help you in your job sets as well.
Basically, it is a designing job.
Design.
It is also.
Right. The next project we are trying to introduce here is an industry-inspired project related to separating layers of different materials. We were interacting with a company called MCE, Mehran Commercial Enterprise, who had a problem of moving a certain equipment, some layers of material from one place to another. They were using a lot of manpower, doing it manually, and they wanted the process to be automated.
So here we have developed a small prototype, and Adit will explain what this does and what sort of output it does and where it's applicable in the industry.
Sure. This is a SCARA robot, and this is used in heavy industries to carry the heavy weights from one place to another place. And in this SCARA robot, we are doing 3-axis movement with the help of stepper motors. We have mounted 3 stepper motors, one on x-axis, one on y-axis, and one on z-axis. And this project we have used Arduino, UNO, and also CNC Shield. On CNC Shield, we have installed our drivers 8825 for stepping the stepper motor, and for suction of the material we have used a sucker which is very capable of carrying the weight of more than 1 kg.
This next project related to a 3-phase and single-phase power supply. It's a trainer that is developed by students of the electrical engineering department. Here we test, amongst other things, live, neutral and ground. We explain how those are interconnected, how the fuse breakers work, and how the fuse button switch and relays are kind of interacting with the main supply, power supply. For this, explaining the purpose of this trainer, I'm going to hand it over to Mr. Mukesh Kumar. He's a lab engineer and an alumni of electrical engineering department. So over to Mukesh.
Thank you, sir. This is 3-phase and single-phase power supply. We use them when we instruct the machine labs to the students, then how to operate the system, how to operate the machines, included generators, motors, and these systems also included fuse. The systems hold 0 to 500 AC voltage because different systems have different capability to work on the different voltages.
Can you also explain the first fuse and button switch?
Yes, fuse and button also used when we use this system. During the practical of the system, we use this relay system for the safety purpose. Because when we use the AC system, this is very dangerous for the students. That's why. Thank you.
The next project is related to demonstration of an unmanned aerial vehicle using relay networks. The students have designed a quadropter. Quad means 4, so you can see 4 different BLDC motors with some propellers which they have locally induced from the market. Everything is done from scratch. This is also a relaying station. So in the payload we have what is called communication relay network established. There is a Wi-Fi router which communicates between one to another person without the other person knowing the identity of the sender. We also have developed what is called a controller. The controller actually is basically an app which controls and which relays, it synthesis information related to the logistics and the well-being of the aircraft when it's flying. So over to Mr. Hassan Vase. Hassan Vase is a lab engineer at the Department of Electrical Engineering. He will explain the different components of the UAV.
So there's actually propulsions, sensors and computation units in this project. And then there's the battery to power up the whole project, and the antenna,
which is used to relay, basically communicate between the controller and the UAV. Yes.
Assalamu alaikum. My name is Osama Mahfouz, and I was the supervisor of this project. The students of electrical engineering have made this eco-friendly marine cleaner as a part of as a contribution to protect our sea, the fishes in the sea and other species from pollution. And I would like to invite Dr. Imran Majid to
Thank you very much, Osama. This, as you can see, is like a small boat which we float in riverines, in small lakes and ponds. And the idea behind it is there is a conveyor belt which segregates fish and animals or organic material from the non-organic material. So as Osama mentioned, he has worked on the segregation part. So you have sensors here attached to the optical sensors. We have some IR sensors, and this is basically using the sunlight to generate the whole mechanism which segregates and stops organic fish from becoming part of the sea and being polluted with the litter and plastic pollution. The next project that we represent at the Electrical Engineering Department relates to the United Nations Sustainable Development Goals, specifically clean and affordable energy sources. We all know the problems we're facing due to hydrocarbon. It has led to 2 cities of Pakistan being highest on the air pollution index. To counter that problem, the students at the Electrical Engineering Department had come up with a novel solution of using electric bikes, which this project referred to as e-bike was funded by Ignite, which is from the Ministry of IT and Telecom. What they have done here in the demonstration is that they have modified an existing bike and converted it to suit an electric charging station. So we will perform now a small demonstration of this experiment that we have performed, and the students have actually developed this in-house using less than 60,000 rupees. It has a lot of market potential and we hope to commercialize it in the future. I'm now going to hand it over to Mr. Abdul Rahman, who's a senior lab assistant at the Department of Electrical Engineering, and he will perform a small demonstration on what he has done with the charging and how long this charging remains, as well as the speed of the bike.
Assalamu alaikum. My name is Abdul Rahman. This is our e-bike, electric bike. We have charged the battery for 2 hours. So if you see, here are the controls, ignitions and the lights, headlights and the horns.
So Abdul Rahman, how fast can this bike go?
So it can go around 60 kilometers per hour.
Which is a very big average for a city like Karachi, and it's very easily commercializable. This actually, the cost was I think less than
60,000.
So this is something which people can easily purchase as well, and we're looking to commercialize this. So the next project that we have on display is related to EHT networks. It's a pure electrical energy transmission, generation and distribution project. The students of the Electrical Engineering Department, under the supervision of their ex-supervisor, they placed a demonstration of real-life modeling of overhead and underground transmission lines for EHT network, which relays up to 220 kilovolt. Here I have with me a very senior member of our Electrical Engineering Department. He's a senior lecturer, Mr. Osama Mahfouz, who will explain the details of this project. Please.
Okay. Assalamu alaikum. The students of Electrical Engineering Department have developed a smart grid trainer, which represents a generator, generation network, which generates voltage up to 11 kVA from DC generation. Then that generation is transmitted, stepped up using the transformers, and it is stepped up to 220 kVA. And then through the transmission network, it is provided to the end users, which contains the hospitals, the residential area, and schools and other premises. The most priority is given to the hospital, as this project is simulated using a smart grid network. So the most priority is given to the hospital. Like for example, there is an overload condition, then the hospital will not be turned off, and the remaining premises will be given other priorities.